Okay, so now we're going to be performing meta regression or ranking. So this basically ranks every single moderator based on how much they contribute to the overall effect size. So just to begin with, I'm going to start with a normal meta regression ranking, just to show you like what it actually does, and I'll go over this function as well. So again, this stores a variable called overall regression, uses the function multi-model inference, and the column that we're extracting effect sizes from is hedge-G. We're extracting the standard error of the effect sizes from seg. Our data is intermediate, and these are all of our predictors. So these are our moderators, and this is going to rank each moderator by how much they actually contribute to the overall effect size. So Control Enter. This actually takes a long time, so I'm going to skip to it and it's done. Okay, so now that it's done, I'm going to print overall regression. So as you can see here, it outputs a neat little plot. And this is what I was talking about with the ranking of each moderator. So the predictor importance is shown here. And how this works is that if we were to segregate all the studies in which medical condition did change with the participants, how to what degree did that contribute to the overall effect size? To what degree did pooling medical condition together actually change the effect size? And that's how this importance is ranked. And we can see that medical condition, participant type, and exercise type are at the very top. And if they're above this blue line, that means that they're significant. So let's move on to interaction regression. And you might have noticed that I didn't mention why interaction equals false here. The reason for that is that these are models based on a single moderator. And typically, if we want an accurate model, we might want a combination of two or more moderators. And this is a principle called fitting. So if we wanted to sort of make a graph of exercise and anger, what variables would we want on the x-axis to most accurately predict the level of anger as a result? And the best way to do that would be to combine the top predictors of anger. So our top predictors currently are medical condition, participant type, exercise type, and intensity. So when we turn interaction to true, it basically finds which model would be the best in predicting anger. So which combination of these four, so medical condition plus p-type, or is it p-type plus x-type, or is it plus 3, or is it all 4? And this, you can only do this with 4 moderators because it takes however many moderators factorial to compute this. So if you had 5, 6, it would take an extremely long time, so you're limited to 4. But that's really all we need here. So let's run this interaction regression. And yes, this takes a very long time, so I'll be back when it's done. Okay, so now that it's done, we can print out the interaction regression. So let's look at it. And we can see that the most significant models still are the singular ones, exercise type, p-type, medical condition, intensity. And we also see that these are pretty good models as well. Exercise type plus participant type, exercise type plus medical condition. So that's the reason that we do this, just to see if there's any other, like for example, with different studies, we might see one of these being ranked higher, meaning that exercise type plus participant type is a far better estimator than just exercise type by itself. And you might be asking why all 4 of them combined would be such a bad predictor. And this is actually called overfitting, where it's good at interpolating data, but it's bad at extrapolating it. So if you have data that's kind of wonky in that it's hard to predict how it will behave in the future, then adding too many variables to the x-axis as predictors is actually bad, because then it works very well with the data that you have, but it's very difficult to predict future trends, which is why this is such a bad predictor. All 4 of them combined is such a bad predictor. Okay, so this RMA function stored in normreg basically lets us test different models, and we can actually test this model just to see how good it is. And again, yi is just effect size, SEI is our standard error, data is intermediate, method is restricted error, maximum likelihood, and our moderators are all of these. And the test equals k, and HA is just the NAP hard time estimator for small sample sizes, as I said before. So normrig, let's run this. Let's look at a summary. So these are the effect sizes shown here. So medical condition is the largest contributor to the overall model, followed by exercise type, participant type, and intensity. And as you can see, the p-values for medical condition and participant type and exercise type were very significant. Okay, so now we conduct a multi-level meta-regression testing all moderators. And we do this by segregating by ID again. And then we perform a regression. So this is effectively the same function we used before, rma.mb, and we're using the same parameters. The difference is we're using a moderators parameter that lets us specify which moderator we want to look at more closely. So I ran it with participant type, and these are our results. So our p-value for participant type is 0.0652. And for this multi-level meta-regression, I'm using a significance value of 0.1. I know that the norm is to use a significance value of 0.05, but since our sample sizes are fairly small, it's better to use a larger significance value for it. So it's 0.1, and if you run a summary, you can look at all of them. So I have them all listed here. So you can really only do this manually because it's difficult to actually put it into a table. Or really it's actually impossible to put it into a table because it varies based on how many moderators you put into here. So it's just easier to just list them here after you do it with each one. So our participant type effect size, our participant type p-value is 0.0652, and this is our effect size. And we're looking at all of these, and we're looking at the ones which are significant. And in the end, with a multi-level meta-regression, the ones that become significant are participant type and medical condition. So these are the ones that we'll finally use to conduct an analysis with our plots.